Now let's talk about the motion of charged particles. So first of all, let's talk about charged particles moving perpendicularly in the presence of a uniform external magnetic field. So moving charged particles. The key feature of the magnetic force on the charged particle is that it is perpendicular to the particle's velocity. Consider a positive charged particle that has velocity along the x-axis. The applied uniform magnetic field is along the y-axis. Then F equals QV cross B gives us QV I unit vector times B J unit vector, or QVB times K. We all know that I times J equals K. The magnetic force will be along the positive Z direction. Here's the thing I want you guys to remember. So I dot I will be 1, J dot J in terms of unit vectors will be 1, K dot K will be 1, right? And any other combinations will all be 0. However, for a cross product, when you think about a cross product, you can easily make this, and I would want to make a smiley face in here. So when I crosses J gives you K. J crosses K gives you I, and K crosses I gives you J. Okay? And I also want you to remember a little sad face. Okay? What that means is if you go the other way around, I cross K will give you minus J. J cross I will give you minus K. And I cross, K cross J will give you minus I. So remember the smiley face and a little bit of sad face. Okay, so this is for cross products. And this is for dot products. So for our particular example, the magnetic force will be along the positive z-axis. Now what about circulating charged particle? So if a particle is moving in a circle, the force of a circulating charged particle will be perpendicular to the velocity and does not change, and this force will not change the kinetic energy of the particle. So what kind of motion will result? Speed is constant. Well, the magnitude of speed is constant and the direction of velocity changes. So this implies the force is not equal to 0 and the acceleration is not equal to 0. However, its speed may remain the same. Magnetic field is perpendicular to the velocity, and the motion will be circular since the velocity will always be oriented inwards perpendicular to the velocity. It is a centripetal force which leads to a centripetal acceleration. The trajectory for a positive charge will be given like this. So it is a circle when it is viewed from above, and the motion will be clockwise. For a negatively charged particle, then the force will be in the opposite direction. That is, when velocity vector is along the plus x-axis, the field will be along the y-axis, and the force will be along the minus z direction. In this case, the motion will be counterclockwise when viewed from above. In a lot of particle physics experiments, that's how we differentiate between positively charged particles and negatively charged particles, because they subject them to an external uniform field. Particles moving in a clockwise direction will be positive, the particle moving in an anti-clockwise direction will generally be negative. Work done on the particle by a B field. Magnetic force does no work on the particle. The rate at which the work is performed is given by power. F dot V equals Q V cross B dot V, and so the total power is equals to 0. V and F are perpendicular. This implies power equals 0. Power equals 0 implies no work is performed by the force. No work implies that the kinetic energy and speed of the particle must be constant. When velocity is not perpendicular to the field, then you resolve the velocity into its two components. One will be parallel to the field and one component will be perpendicular to the field. The magnetic force is associated only with the perpendicular component. Since the cross products are distributive, we can write the cross products as QV times B will equals QV parallel plus V perpendicular times B, or QV perpendicular times B, because the parallel component becomes equals to 0. The force will be perpendicular to the field and perpendicular to the velocity component. In this case, the motion will be helical, like this. So the particle, if you were to think about it, it will go up as it goes forward. Example. In a mass spectrometer, a beam of lithium-6 and lithium-7 ions pass through the velocity selector so that ions all have the same velocity. The beam then enters a region of a uniform magnetic field. If the radius of the orbit of lithium is 8.4 centimeters, what is the radius of the orbit of lithium-7? So in order to understand this problem, we have to understand what a mass spectrometer is. So mass spectrometer is basically an instrument which can measure the masses and relative concentrations of atoms and molecules. It uses a very basic knowledge of magnetic force on moving charges. What happens is charges are ionized here, then they are applied, and then an accelerating voltage is applied, so they're basically forced to go through a magnetic field here. Once they go through a magnetic field, they are put into a field, and for example, this is a field pointing out of the paper, and different sizes and different masses with different speeds will go towards the detector on this side of the mass spectrometer. Now, in this case, what are we given? We are given a uniform magnetic field, and we are given the radius of, so we have a uniform B field. We have a radius of lithium-6 ions, which is 8.4 centimeters, and we are required to find the radius of a lithium-7 ion and use a mass spectrometer. Now, we know that a mass spectrometer will make things go in a circle, right? So this is what we know for a mass spectrometer. What else do we know? When things move in a circle, we have sigma F equals the force that's causing it, from Newton's laws, right? When things move in a circle, we have mv squared over r equals fb, right? Now, what is fb? FB is QVB, because the direction of B and V are perpendicular to each other. So B is coming out of the page and V is going this way, right? So we will get mv squared over r equals QVB. So one of the B's get canceled. What are we looking for? We are looking for r, so it'll be mv over QB will give me R. Okay, excellent. Now, this means, what do I need in order to solve this? I need to calculate, I need radius of the lithium-7 ion. So if I can find the radius of the lithium-6 ion, I can find radius of the lithium-7 from there. So what I'm going to do is I am going to say radius of lithium-7 divided by lithium-6 will be mass of lithium-7 velocity divided by QB over mass of lithium-6 V divided by QB. Now, both are ions of basically lithium, so Q's charges will be the same, velocities will be the same, and B, are they being exposed to the same B? Absolutely. So this will get canceled. What am I left with? I am left with mass of the lithium, that. Now, if I only knew what the mass of lithium-7 ion was and lithium-6 ion was, I will be able to calculate the radius, which is easy. You can always look it up. And I find that this is going to be 7.016 U, and this is 6.015 U. Okay? U's get canceled, right? And this is given to me, which is what? 0.084 meters. I can calculate it, or actually even I don't have to convert it to meters. I could leave it in 8.4 centimeters, because then I can calculate the radius of the lithium-7 as in centimeters. And what I find is when I plug everything in, it's about 9.8 centimeters. A cyclotron. A cyclotron is a type of particle accelerator. Cyclotrons accelerate charged particles using high-frequency alternating voltage or potential difference. Perpendicular magnetic field causes the particles to spiral almost in a circle, so they recounter the accelerating voltage many times, getting faster and faster and faster every time. The largest cyclotron in the world is housed at the Tri-University Meson Facility, Trump, at the University of British Columbia, Vancouver, Canada. So a little bit about mathematics of a cyclotron. We know the magnitude of the magnetic field is QVB, where V is a component of the velocity perpendicular to the field. Assume no velocity is parallel to the field, so the above velocity is really the particle speed. Since B is always directed towards the center of the orbit, the acceleration is equals to the centripetal acceleration, V squared over R. Then the radius of the orbit will be given by mv over qb, just like the one we did solve on the board in the example before. The period, which is the time for one full revolution, will be given by, since it's in a circle, it's moving in a circumference, 2 pi r over v, which is equals to 2 pi. You can plug the value of r from here into here, and that will get cancelled. The v's will get cancelled, and you will get 2 pi m over qb, which is very interesting. The thing to note is that the period is independent of the velocity of the vector. It is going to be given by 2 pi m over qb. All of those terms that only depend on the integral particle that you are using. The frequency, which is the number of revolutions per unit time, is given as 1 over t, or bq over 2 pi m. Again, all of these terms are fundamental. B is external, E is the charge, and m is the mass of the particle itself. It has nothing to do with the radius or the velocity of the vector. So angular velocity is going to be given by bq over m, frequency given by bq over 2 pi m, and kinetic energy will be given by 1/2 mv squared, or q squared b squared r squared over 2m. Example. A proton cyclotron uses a magnet that produces a 0.60 Tesla field between its poles. The radius of the Ds is 24 centimeters. What is the maximum possible kinetic energy of the protons accelerated by this cyclotron? So in this case, what it tells us is that the cyclotron, a proton is moving in a circle, right? In an external magnetic field, which is 0.6 Tesla, and the radius is 0.24 meters, and I have to find the maximum kinetic energy, okay? What do I know? I know kinetic energy is 1/2 mv squared. Now my problem is, how do I find v? What do I know? I know sigma F equals Fb, because the only force that is acting is the magnetic field. I know that since it's moving in a circle, this should be mv squared over r, or qv cross b, but the angle between v and b is 90 degrees, so it reduces down to qvb. Okay, this gets cancelled. What do I have? mv over r equals qb, or v equals qb r over m. Okay, that I can plug back in here, right, to give me 1/2 m q squared b squared r squared over m squared. Yes? This means this gets cancelled. What do I have? Q squared b squared r squared divided by 2. Once I have all of those terms, all it's left to do is plug in the values. What is the charge on the the positron in this case? It'll be 1.6 times 10 to the minus 19. what would be the mass of the proton? In kilogram, it is given by 1.67 times 10 to the minus 27 kilograms. R is given as 0. Sorry, that doesn't look like an R. R is given by 0.24 meters. And that's pretty much all you need, right? And oh, B. B you need also, wait, I'm missing an M here. That's what I was thinking. Okay, so there's an M missing here, and then B will be 0.6 Tesla. Plug all of those numbers in to give you kinetic energy equal to 1.6 times 10 to the minus 13 joules.